For this example on how to evaluate the limits at infinity for radical functions, the same set of steps will be applied. Given the limit as x approaches infinity of root x squared plus 5x minus root x squared minus x all over x, how do you evaluate this limit when you have multiple radical expressions? Remember, you rationalize, meaning we multiply both sides by the conjugate. And given root a minus root b, the conjugate will be root a plus root b. You still remember? Now we are going to apply that to this expression. So we'll have the limit as x approaches infinity of the entire expression, the root x squared plus 5x minus root x squared minus x, multiply its conjugate. Remember, we just flip the sign, which is root x squared plus 5x. Instead of minus now, we have plus root x squared minus x all over the denominator, multiply the conjugate, which is root x squared plus 5x plus root x squared minus x. You still remember, we can write the numerator as difference of square. So we will have the limit as x approaches infinity of root x squared plus 5x minus root x squared minus x all squared all over x multiply root x squared plus 5x plus root x squared minus x. If we go further to evaluating that expression, what we will have left will be the limit as x approaches infinity. So we simplify. If we expand that, we are going to have root x squared plus 5x squared minus root x squared minus x squared all over x multiply the entire expression there, which is x squared plus 5x plus root x squared minus x. We see that this root can cancel this root. The square can cancel out the root. The same thing happens here. Therefore, we will have the limit as x approaches infinity of x squared plus 5x minus x squared minus x will give us plus 6x plus x all over the denominator remains the same, x squared plus 5x plus root x squared minus x. We can see from this expression that x squared cancels out minus x squared, so we have 5x plus x left, which will give us 6x. So this will equal the limit as x approaches infinity of 6x all over x multiply root x squared plus 5x plus root x squared minus x. From this expression, we can also see that x can cancel out x here, so we have 6 left. And the next step is that we factor out the highest root in the expression here. Now, if we do that, this is what we are going to have. The limit as x approaches infinity of 6 all over. Now let's factor out x squared. So we have x squared multiply 1 will give us x squared plus 5 will give us 5x squared, but what we have here is 5x. So how do we make it 5x? We just divide by x. And this part of the expression is done. Plus root 1 multiply x squared will give us x squared, so that is balanced, minus 1 multiply x squared will give us x squared, but what we have here is x. So to make sure it is balanced, we divide by x. So this expression is balanced. Now, having done that, we can see that root x squared is the same thing as x. We have established that, right? So if we write this out properly, this is what we have there. We have root x squared, right, multiply root 1 plus 5x plus 1 minus 1 over x, right? That is what we have. So let's rewrite this properly. We will see we have the limit as x approaches infinity of 6 all over, since root x square is x, we have x in 1 plus 5 over x plus root 1 plus 1 over x. We can now do direct substitution here. As x approaches infinity, we are going to have the limit. We are going to have 6 all over infinity multiply root 1 plus 5 over infinity plus root 1 plus 1 over infinity. And if we go further to simplify this, we see that 5 over infinity is 0. The same thing, 1 over infinity is 0. So we have root 1, which is 1 plus 1 here, which is 2. So we are going to have 6 all over infinity multiply 2, which is 6 over infinity. And 6 divided by very large number will still give you 0. So this will give you 0. The answer here is 0. If you find this video helpful, please like, share and subscribe to our channel. Thank you for watching.